Alright, let's begin. Hello everyone. So today I'm gonna talk a little bit about Alan Kay's OOP talk. So you can search it on YouTube, Seminar with Alan Kay on Object-Oriented Programming, VPRI 0246. So note that I'm only paraphrasing what Alan Kay said here. So please watch the video for yourself. And furthermore, if you don't know what OOP is already, you might want to chew on something easier than this video. With that out of the way, so first of all, the idea of OOP was inspired by biology. Alan Kay said that biology systems have like 1,000 times more parts than man-made ones. Each of them is significantly more complex, and nature's solution to manage the complexity is to make cells so that each cell is concerned with protecting itself and communicate with other cells. So okay, I think that's one solution, but doesn't say that it's a good solution though. So computers can do things that humans cannot do, and that's why we need them in the first place. And furthermore, you don't need a machine with billions of parts, because why would they need to have billions of parts? Each part of a program serves a purpose, unlike in nature where most of the stuff are entirely useless. For example, why would men have nipples? So what Alan Kay said meant by data structures is that they are transparent entities that if you give them to somebody, they can change it however they want. So objects are more sophisticated and they are more protected because they encapsulate also behaviors and methods and not just data. So the only thing that you can do when you have an object is that you can ask it to give information about itself or to change some information about itself. So one example is that modeling of fractions. So in the data structure way, you do this. So you just set up a simple structure like fraction. You have the numerator n and the denominator d. So the way you use it is that you define the z right here to be a fraction of 5/3, and then you access n, and then you set n to 0, and then you access again, and then it changed. But then here's the problem. You set the denominator to 0. And what you learn in math class is that the denominator can never be 0 because you cannot divide by 0. So how do we solve it? Well, we can solve it the OOP way. So you make a class fraction like before, numerator, denominator, but then you say that whenever you make an instance of this class, whenever you make a fraction, you must use this constructor right here. So here we have the protection comes into play. So d is protected. So if the input d is 0, then it errors out because the denominator cannot be 0. Otherwise, yeah, it does the same thing as the structure. And then you have the getters and the setters. So earlier I said that objects cannot expose their fields, so you must have these methods for an object to express itself. So you have getters and then setters, and here the setters again. You see the protection idea is in play again, because again we check if the input is 0 or not. If it is 0, then log error saying I'm not setting my denominators to 0. but otherwise it's set D to D. So the usage as before, N doesn't change, but when you set D to 0, then it locks an error. I'm not setting my denominator to 0. So then when you look at Z again, it doesn't change. Get D, it doesn't change to 0. Okay, so the lesson is, if we can restrict the way in which data can be constructed and mutated, then they can never get to an illegal state. So far so good, but what about performance? So there are cases where you like to bypass the zero check. For example, like a loop right here, looping x for 1 to like a million. You make a fraction with denominator with x. So with the class method, then we run into a problem because x gets compared to 0 every single time, a million times. But we know here that x is never gonna be 0. So it's a waste of time, and this is an example of being safe but also sorry at the same time. So a counter to that may be that, well, we're using a high-level language, so you don't need to be that fast. To that I say, sure, okay. And then he compares Smalltalk's 40,000 line of code to the Unix kernel's 400,000. And I'm gonna say that comparison is not gonna fly, dude. These languages are solving completely different problems, and they have completely different performance characteristics. So if your language is high level, then you don't get to compare yourself to C and feel good. Another problem I raise is that how are we gonna model binary functions? So the challenge is that you can sum fractions. Many people will jump in and do this. They implement the class fraction like before, and they stick the method add right in here, accepting another fraction and then returning this right here. So the way you use this is that you say z1.add z2 to mean z1 plus z2. To that I say, what? Why must we think of adding two numbers as sending a message called add to the first number? And even if you add some syntactic sugar to write it as z1 plus z2, you haven't solved anything. The underlying problem is still the same. So we could do better than this. We use a technique called a static class. So you make another class named math. It has a constructor which does absolutely nothing. And here you have a method called add that is supposed to add two fractions, z1 and z2, and return another fraction. Okay, notice that the method has nothing to do with the class math itself. It also has something to do, it only has something to do with fractions. So if the usage looks a little bit more clean, we have let math equal math, then we use it right here. Okay, it looks better, and with polymorphism we can define a general addition method for all classes, so that's good. However, notice how verbose the code is. Like, look at this. Ugh, yuck. So every single field access is a goddamn function call. And don't you tell me about getters like z1.n that translates to z1.getsn. You're just sliding things under the rug here. Getters and setters, I say, invent a new syntax that does literally one thing, making field access and mutation less painful. They add nothing to the table. And Alan would surely refuse the notion of direct field access as valid OOP anyway. and yet he does not acknowledge the importance of raw data structures, calling them dumb, etc. Well, to that I say a flashlight is dumber than a smartphone, but smartphones don't invalidate flashlights. And well, if you leave people no choice, they'll invent a horrible hack around it, like getters and setters. So an even more severe problem is that the existence of the class named math. So what is that class supposed to represent in the real world? Can I make multiple instances of it? If so, will they behave the same way? And why isn't there simply a default class named function where I can put all my functions in there? Oh, by the way, real OOP languages solve the problem with static classes, which is another hack. And by the way, that's a non-problem in normal languages. You're just defining a function, add, and be done with it. There's no object where it's supposed to belong to. Alright, by this point I've covered about an hour and a half of the talk, case talk, not mine. But a final thing that I also noticed is that Alan Case seemed very fixated on the notion of programs that you should model the world. So first of all, modeling is not the right thing to do, not always. So 3D graphics model the world better than 2D ones, but they certainly don't look better, do they? One may argue that programs that model the world closer are easier to understand. And maybe that's true, but only maybe though. And second, all machines aren't capable of simulating the world. That's why we don't just do ray tracing just to simulate light. So on closing notes, first of all, I'm just criticizing points from this talk itself, which was done like 30-40 years ago. I do not claim to know the entire OOP state-of-the-art paradigm. Also, I know that Alan Kay couldn't have said everything in just under 3 hours, without notes by the way. And it's a great talk, which has many good points that I didn't touch on since I only want to critique the talk. Again, I strongly urge you to check it out. Anyway, hope you guys liked the videos. Comment, subscribe, and like if you want to. And goodbye.